Those of you that have labs in the ME building should already have received the self-audit form in hard copy form in your mailbox. If you haven't picked it up yet, it should be there. So the purpose today is to help you fill out those forms. Those forms are due back into Rick DeWall by February 1st, so you have several weeks to finish those. What I wanted to do before I turn it over to Jim is just show you the ME website. So over here on the left, under About Us, is the Safety and Emergency Information link. And in particular, what I want to refer you to is the lab safety link. And it indicates some policies, but also there are some links to some information about HAZCOM and PPE, as well as some links to safety training. Many of these are links directly to REM. And so if you need to train your students, and they should be renewed every year, on things like hazard communications, that information is available directly here on the website. The other thing that's here is up there is an electronic version of the same form that you've got in your packet, in your mailbox. And so the advantage of this is that you can go through it, and if you have questions on any of the pieces, there are direct electronic links here that you can go to for further information, as well as to get some of the forms that you need to have for documenting things like training records or defining your hazards in your workspace and so on. So this information should be extremely helpful to you. If you have further questions based on having gone through it, and maybe you have questions on what's there or what isn't there that you're looking for, let me know and we'll try to update that. Otherwise, without further ado, I'd like to give you the floor to Jim Schweitzer, and he'll tell you more about safety.
Okay, thanks. We got a packed house today. That's good. So I'm always happy to help, no matter what. And also, if there's contact information for all my staff, including myself. So if you can't find a satisfactory answer, or a lot of times OSHA provides interpretations of sometimes their complex regulations, we can help interpret those and see what the application is to your particular laboratory. So do not hesitate just to send me an email. If you don't know who to talk to in REM, send me an email. So I'll be happy to do that. So what I wanted to do is just go through and review a few things that we find that is, I don't know if it's troublesome or confusing, but if you don't work with it every day, oftentimes it can be, what exactly do I need to do? So hopefully I will go over some of these, and hopefully we can make it clear, or it may generate some additional questions that I'll be happy to answer. So just a few basics. We change that form all the time. And why do we do that? Well, we do that because of feedback from people like you. This question is not very clear. Or we do it on feedback from my staff. We meet on a quarterly basis to say what's right with the form, what's wrong with the form, and what can we change to make it clearer, to make it and people understand it, and then figure out where to steer people for the right training requirements or compliance requirements or forms. And each room should have a form. So we're flexible, so if you have like 3250 A, B, and C, and they're connected, you can use one form for those. But what we're trying to do is say, if you have this room and you fill out a form, you really can't take that form and go down the hall or go down to the first floor and do another room, because you've already checked for the compliance in this area. So unless they're closely connected and have the same things going on, then we look for another form. And then all the portions should be completed. I know in many cases they just don't apply, but rather than having multiple forms for, let's say, a form for chemistry, a form for ME, a form for liberal arts, we have one form, and then you can very typically, check NA and move on to the next section. And then the responsible individual should sign. The responsible individual does not need to do this audit, but the responsible individual makes sure it's done and that the person doing the audit has the appropriate level of knowledge to do it properly, and whether or not they have any questions. So as I said before, you can answer no to the first question and then move on to the next one. However, a lot of people want to say, well, this doesn't apply to me. Well, if NA isn't an option, we've determined that it needs to be a yes or no answer. So we're looking for a yes or no answer in that case. And as Peter said, we have lots and lots of links, hopefully to steer you to the right information so you can answer the question accurately. And then the type of room might dictate how much of the form to complete. In a lot of cases, areas that really don't have any hazards, office areas, administrative type areas, you only need to go through the first 7 sections. Then you're done. So just read the instructions in there and it will tell you that. So a big question is always personal protective equipment. How do I know what to wear? How do I do it? Well, first off, you need to do a hazard assessment to determine what the hazards are. And then once you determine what the hazards are, through our hazard assessment form, which is on our website, you then determine what is the personal protective equipment. And so the minimum for a chemical hygiene plan laboratory, lab coat, safety glasses, and then hopefully, obviously, long pants and closed-toed shoes. So no flip-flops or sandals or anything like that. So what we're doing is the biggest thing that we see in terms of chemical exposure are spills. And if you have exposed skin, legs or below the knee, they can become contaminated. So you only need to do one version. We have various versions. So in some areas, people want to do it by the task. So when, perhaps let's say you're using hydrofluoric acid, you may decide that you want to do that particular one by the task because you need to wear a lot of additional personal protective equipment. For other ones, you can decide that I'm going to do this for the location. So in room 2150, here is my hazard assessment and then the determination of the personal protective equipment. The good news is you do it once. You don't need to do it again. As long as you have it, it's current in terms of being accurate, then that's all you need to do it. Unless things change or a new hazard is introduced. Then you need to go back and reevaluate that. But it's always good on a regular basis to go take a look at your hazard assessment, say, yes, that covers all the hazards that I have in this particular space, and then it then specifies the personal protective equipment. And then the other thing is that, well, how do I train my people? Well, oftentimes people say, well, it's sort of dumb to train people on how to wear safety glasses. Well, maybe. That's very simple personal protective equipment. However, OSHA looks at it in terms of they're putting all personal protective equipment into one bin. So whether it's safety glasses or, let's say, fall protection. If you don't put a fall protection harness on right and you fall and it's not protecting you, you probably die or are injured. So how do you do the training? Well, you just observe everybody putting it on. So, okay, don your safety glasses, don your lab coat, don your gloves. You're looking good, you're trained. And all you have to do is just document that. You just need to do that once. However, it might be good just to review what personal protective equipment is needed in that laboratory to make sure everybody, including the new students, and they need to get that training. So oftentimes people say, we're just going to train annually. Everybody, we're just going to review it, and then the new people automatically get it. So it's pretty simple. And then we'll talk a little bit about the retaining of those training records in a further slides. So chemical safety, this continues to cause questions and perhaps confusion among a lot of people. So the question we get is that I have a lab. Well, Is it a chemical lab? And so we need to define the laboratory, and then we need to pick which training will apply to that particular laboratory. So if you could be in the hazard communication program, we call that HAZCOM, or the chemical hygiene plan, we call that CHP, or perhaps in some cases, you can have both. And so you may have people working in the same space that really are chemical hygiene plan people and other people that are hazard communication. So let's talk a little bit about that. So hazard communication, the first thing is, did you have people that are exposed to hazardous materials? Well, however, it's designed for people that are using typically off-the-shelf products. So let's say that the only thing you do is you use some WD-40 to lubricate some things in your robot, and you don't really use any other chemicals. You're likely going to be in the hazard communication program, and that will trigger some things. And typically, generally, it's not applied to research labs. And so the examples of things that people might do, cleaning, painting, gluing things together, those types of things. And so there are specific requirements for that, and these come from OSHA, and we try to communicate and comply with OSHA because, unfortunately, OSHA comes on campus. And you guys might know sort of a funny story, not very funny really, but the clock tower incident, many of you have seen the thing on YouTube. Well, OSHA showed up the next week because there were some safety issues there, and they called that a media referral inspection. Somebody saw it on YouTube. And so we are liable to have OSHA inspections at any time. Someone gets injured in a laboratory and we need to report that because they're hospitalized overnight. That's pretty much a guaranteed visit from OSHA. And what is the first thing they ask us for when they come in? Show us your hazard communication program. Show us your injury statistic. So if we don't have this, then that really puts us behind the 8 ball with OSHA. And if it doesn't start off good with OSHA, then we're going to have a lot of work to do in the future. So here it is, initial and annual training. Again, that training is on our website, really easy to do, not that long. Maintain safety data sheets. So every time you get a product, you should be able to either get it with the product or research it and print it off or store it. An inventory of all chemicals. So all the chemicals you have in there, as you get new ones, put it on your inventory. And then you maintain the original labels and then label secondary containers. So as much as possible, keep the stuff in the original containers, but if you must, put it in a secondary container and then label that secondary container. So typically, we have these labels, so if you ever need to put stuff in another container, we can provide you with all these labels. And we need to have everything labeled because, if you're doing research and you graduate and you leave a nice big container of something that's not labeled, what is it? Well, you knew what it was. We don't know what it is. Anybody, you can't tell the difference between methylene chloride and water by just looking at it. And so that for us is problematic. So only in the HAZCOM area. So if you're a hazard communication program lab, then we can provide those labels. If you're a chemical hygiene plan, you can just label it with the chemical name, so it doesn't need this. So you can actually, on this particular label, you can actually, whatever doesn't apply, you can peel off. So you could peel all these different things off and just leave the one that applies. And so it's sort of a universal label that makes it pretty easy. Yes, sir.
Those labels?
We do. We do, as a matter of fact. Tell us how many you want. If you want 100, we can give you 100. So these things are obvious. Legible handwriting, no chemical formulas. If it's water, don't put H2O, even though everybody knows. And then if abbreviations are necessary because the length of the chemical, then all you need to do is have some type of legend somewhere. So post a legend in the lab. So if you want to do, you know, TEDA or whatever you might have, post that legend, and then you can go see what it is. So, fairly straightforward. So those are the requirements for the hazard communication program. Chemical hygiene plan. It's reserved for the laboratory manipulation of chemicals. And that's sort of broad, but if you think about it, a bunch of chemicals, pouring, making, diluting, aliquoting, all that kind of stuff. Or there's multiple chemical processes used, but it's not a part of production process. So glue number 1, glue number 2, or whatever. And then you have laboratory practices and equipment available to minimize exposure potential. So we have fume hoods, we have personal protective equipment, or other engineering controls that can help. And so really the chemical hygiene plan was designed for people who have an understanding of the chemical processes and what goes on in a laboratory. And the hazard communication program was meant for people like, let's say, a custodian that doesn't have an advanced knowledge of chemicals, but needs to know about these chemicals to be safe working around them. So you need to have a laboratory-specific chemical hygiene plan. We have a template on our website that you can, without too much trouble, that you can modify to fit your lab. You need to have standard operating procedures, and we have over 60 standard operating procedures on our website. So if you want to have a standard operating procedure for working with, again, hydrofluoric acid or something like that, we have many of those, and we're happy to make more if you need some for a particular chemical. And then follow the components of the chemical hygiene plan. It sort of spells out labeling, personal protective equipment, and those things. And then initial and refresher training. So the initial training you can get by working or doing our laboratory safety fundamentals on our website. And that's, you do that. And we are working to augment that with some refresher training that we'll put on our website that then applies to laboratory safety again. Or you can come up with your own training. It might be as simple as, okay, we meet once a year, let's review our hazard assessments, the safety things, any injuries, and document that, and then you've done your refresher training. So that's pretty straightforward. And you can just do that during a lab meeting and have people sign off that we covered the safety aspects for refresher training. So I had these same pictures last year, and so it's a little bit of a quiz. So what are these areas? Are they chemical hygiene plan areas or HazCom? The one on the left looks like that's probably going to be chemical hygiene plan. The one on the right, if you look at those two containers to the right-hand side, those sort of have the hazard communication labels on them. So those might be those secondary containers I was talking about. So that could be a HazCom lab. And you don't really know, you can sort of guess. You don't really know until you actually dig down. And again, the one on the left, probably a chemical hygiene plan because we have multiple containers. Perhaps if they're the same chemical that are used for the same process, it might be hazard communication. And it looks like there's some 3D printing material. That's probably, if that's all that's done in that laboratory, that might be a HazCom lab. And again, these are probably likely chemical hygiene plan laboratories because of the different multiple chemicals, and it looks like there's manipulation of chemicals. And if you do have any questions about that, one of the things that we do is as we do our walkthrough, we'll do that I think in March or April, we will figure out and then consult with you. If somebody says, well, both, or I'm not sure which one, it's not the end of the world. We'll talk to you and figure out what best suits your particular research. Electrical safety, again, when stuff breaks down in the laboratory, we want to fix it. And so oftentimes we'll open up the back and say, I think I can do this. I know enough about electricity. Well, that's fine and well, and maybe you do. However, you need to have electrical safety training before you do that. So what we would do is provide that training to you. You can develop standard operating procedures, but we'll document that training. Again, we want to make sure that everyone is competent to do that? Well, you may be competent technically. We want to make sure that you're aware of the regulations that apply to that. And a lot of these are sort of intertwined in terms of application, and I'll show you what I mean in just a second. Hearing conservation, a lot of people say, well, it's really loud in here. I need to have earmuffs. Well, you can certainly do that, but REM is happy to come out and actually do an evaluation. And we'll do an evaluation to determine the noise levels. And then if they exceed 85 decibels on a regular basis, that's when we need to put you in our hearing conservation program. And so what that would be is that you would get a hearing exam on a regular basis. We would train you on how to wear hearing protection and those types of things to make sure that you don't get exposed to excessive noise levels. But most of the time, it is loud. If you have to yell when you're talking to the person next to you, it probably is an area that should be in the hearing conservation program. We should look at maybe some noise abatement or working to provide the hearing protection for those folks. Respirators. Again, another area that some people decide, well, you know, I'm working with the stuff and I'm going to wear a respirator. Well, that's fine, but there, again, through OSHA, there's a number of requirements regarding the use of respirators. So the question is, are there these respiratory hazards in the laboratory? And if the answer is yes, then what we want to do is help you evaluate that laboratory and determine, are you required to wear a respirator? We obviously would prefer that you work in a fume hood or something like that to prevent us from, you know, people needing to wear a respirator. However, if you need to wear one because of, let's say, tasks that happen from time to time, we need to determine whether or not it's required, and if so, the individuals must get a medical exam. And why is that? Well, we want to make sure that you are fit to wear them. You know, I don't know if you've ever worn a tight-fitting respirator, but after about a half an hour, it's sort of taxing on you. And if you have to wear that all day, we want to make sure that you're fit to do that. In addition to that, we'll train you on wearing it, cleaning it, replacing it. Because there's nothing worse than to wear a respirator that's not fitting properly and it's exposing you anyway. So that's even worse, is that it's just a hassle. However, a lot of people say, I want to wear a respirator because we have some nuisance dust. So let's say you're sawing wood or cutting a metal and you get some particulate. We can do that. So what we need is for you to fill out an Appendix D to make sure that, you know, this respirator is only worn for comfort and you're not exposed to any hazardous materials. So the answer is yes, you can do it. And so typically as I walk around, I'll see a respirator somewhere and I say, you know, what are you using this for? And what we'll do is figure out you should be in the program or you need an Appendix D. And then the other thing is to making sure that it gets stored properly. So a lot of times people working in a fume hood, I see a respirator and it's hanging on one of the gas knobs right there. Well, that's fine. But however, it's not protected from contamination. It's not, other people might use it. I don't want somebody else using my respirator. And so what we typically do is when you're done using it, you can make sure it gets, you know, if you're using it for a long time, it can get a little bit of moisture. Make sure it gets dry. Put it in a bag for future storage. And once the reusable ones, you can use those for a few times, and then after a while, just throw that one out and get a new one. The elastomeric, you can use like ethanol pads or some types of wipes. You want to routinely do that because oftentimes if you don't, you can get some facial irritation. So yeah, we see a lot of times when we see them just lying around, that raises some questions. Equipment. So we often work on equipment, and that's good as well. Sometimes it's unique equipment that no one else can really work on, but we want to make sure that people working on it utilize the proper safety things. And, we don't want people, working on, let's say, a machine that has a pulley and flywheels, we don't want people taking the guards off and working on that because it can cause some serious injuries. And again, you know, going back to the OSHA story, we actually had an injury at Purdue where an individual amputated part of his finger. Because of that, he was working on it and he didn't lock that out properly. Again, OSHA shows up to discuss that with us, so it takes a lot of our time. So really what we want for the most part is for people to be able to clean, service without removing the safeguards. And so safeguards include any type of energy, electrical energy, you know, those types of things. So, however, we realize that there's going to be some times where you have to service machines, you know, without the guards on and things like that. So what would happen is that you would then enter into the Control of Hazardous Energy program. A lot of people call that lockout tagout. So what we want to do is make sure that people are appropriately trained and know to lock out equipment. And unfortunately, we have another OSHA story where individuals were servicing a piece of equipment. It was not locked out. The electrical supply was still on, and that individual had a serious shock. OSHA shows up again. So those are the things that we want to do, is to make sure that that individual, they should have made sure that they locked out the electrical energy at all points. So again, we're happy to help you out in developing a lockout tagout plan for your equipment that needs to be serviced and has the ability to be energized. And oftentimes, if someone goes in a remote part of the lab to work on something, somebody else comes in, flips the switch on, and so there could be some situations there. So,
does that have to be repeated once you're trained for lockout tagout?
yes, it does have to. I think there is annual training on that. And again, because the reason for that is that a lot of times these procedures that where you need to lock it out, people only use it, you know, once a year or once every 2 years. So they need to be refreshed on that before they use it. So we're happy to help and help you develop training and information. Things that we see a lot of, so some things that we see a lot of is that people think that they want to be efficient and save money by reusing disposable gloves. Disposable gloves are disposable. So a lot of times we'll see them out on the lab bench, and you can sort of tell if they've been used before. So if you're using these types of gloves, wear them once and then dispose of them. The other thing is that if you take them off, it's really hard to get them back on without, let's say they're contaminated, hard to get them back on without contaminating your hands. So use a fresh pair. However, there are reusable gloves. So if you're working in a sodium hydroxide bath and you need some more sturdy gloves, so put your disposable ones on, put these reusable gloves on, let's say when you're washing equipment or whatever, and then at the end, wash your hands and wash the gloves. So wash the contaminants off and then hang them up to dry, and then those can be reused. But you know that you can tell the difference. These are a lot more sturdy, but after a while these are going to wear out too. So make sure there's no holes and those types of things. So we see that a good bit. Training records. So OSHA again is quite complicated on training records. So our philosophy is that maintain the most recent training record if refresher training is performed. So if you do refresher training, you can throw out the old one. However, look at item number 3. I'll talk about it in a second. However, if you don't do refresher training, maintain that original training. And if you have training for a particular individual, I think our lawyers would advise us to try and retain those if possible. So think of the scenario where a grad student works at Purdue here, and 5 years later he gets cancer, and he or she comes back and says, Purdue didn't train me on this particular thing. And we go to that file and say, yes, we did. That's good news there. So if possible, put those training records in a personnel file or in a place in the laboratory that can be maintained. So not a requirement, but probably a good practice. So talk a little bit about the hazardous chemical management. This comes up a good deal. So I want to show you some good pictures. So and then I'll show you a few not so good pictures. So don't overcrowd fume hood benches. Store incompatibles separately. So again, you know, this is a good organized area. Again, nicely organized. Looks like everything, with the exception of a few things, is in the original container. The labels are legible. Don't store liquids above eye level, because when you do that, let's say the cap is loose, you go get it, and you could end up pouring it on yourself. So as much as possible, just store consumables and things that are light. And then if you do have things that, liquids that need to be stored above eye level, you should just have a procedure or a label of what to do. And so, for example, if they're on that top shelf, you might have a label that says, use step stool to access these chemicals. And then people are reminded that, yeah, I'm not going to try and reach up there and do that. Flammable liquid storage. Our guidance is that you should have a flammable cabinet for more than 10 gallons of flammable liquids. Don't store oxidizers in the same flammable cabinet. Corrosive chemical storage. Keep acids and bases separate. And don't store metal chemical containers with corrosives. So you see that container up here? It's not looking too good, is it? I can't even read what it is. So that's difficult. Again, there's another one. That's a metal container over there. It's sort of looking all fuzzy, everything. Improper chemical storage. You know, we don't stage these things. And this was actually some more war stories. In this laboratory, the custodian picked up trash from this laboratory and dumped it in his cart. And about a minute or two later, the cart was on fire. And luckily, he was able to roll it quickly out of the building, but the cart and the trash can were totally consumed. So again, this, how do you even know what you have? Nothing is labeled. Open containers. From the same laboratory, you can see the chemicals are stored on top of one another here. It's good that they're all in their original containers, but this one is looking like it wants to fall. So again, some more. It looks like somebody was cleaning things, and they might have had a base bath in the middle, and that's dried out. And then on the right, you can see that this one chemical container here is looking all fuzzy. So we're happy. We will pick up chemicals all the time. If you find out you don't need it, it's expired, starts to look a little rough, let us know, and we'll pick it up. And again, just label stuff. You can see this is labeled as an oil bath. Certainly might be obvious, but it's good to do that. So when the next person comes along, they'll know, oh, this is just water. I can just dump it. It makes it so much easier. So legible handwriting, no chemical formulas, and then keep that legend as I talked about. So talk a little bit about just some background for you. We pick up a lot of waste. This year, we had a record year and picked up almost 240,000 pounds of chemical waste. A lot of waste. We had over 35 or close to 3,500 pickups from individual laboratories, and we had over 30,000 individual containers. what do we ask for when we come to pick it up? Keep the solid and liquid separate. Put it in a container that's compatible with the chemicals. And use a Purdue hazardous waste label. And I'll talk some more about that. So spell out the chemical name. Give us an approximation of the percentage of the waste in the container, and then identify the hazards. So fairly straightforward. And so what we're looking to do is to make sure that when you give us that container of solvents, that perhaps there isn't a trace of, let's say, heavy metals like mercury, which really makes, for us, we commingle these drums, or the containers, into drums, and if we have mercury contamination in a drum, it really, the cost goes way up, and our credibility gets sort of eroded with our waste vendor, who trusts that we label these things appropriately. And so we could put, if there was something incompatible, we could put our vendor and their staff, or even my staff, to process it in harm's way. And then if you have chemically contaminated sharps, needles, blades, you name it, just use a sturdy container. It doesn't need to be red. It can be anything as long as it's sturdy and labeled as sharps, and separate it from the other waste streams, because we'll handle that a little bit different. So if you're just using a lot of pipettes, Pasteur pipettes that are sharp and have a little bit of chemicals in them, don't put them in the liquid, put them in a box, a sturdy box, and make sure the other thing is that needles and things can't poke out of it.
You guys pick up sharps containers too then?
Yes, we do. We do. If they're chemically contaminated.
Okay, yeah,
So if there's chemicals. Yeah, if they're just sharps, then those would go through building services. Just, make sure that nothing pokes out.
Right, okay.
And then if they're contaminated with biological material, we will pick them up too. So if you just have debris, like paper towels, Kim Whites, plastic things, little trays and stuff like that, collect those separately from the sharps. Take all the silica and filtration or column material out, and then double bag in a garbage bag. And then you can put one of our orange labels on that garbage bag, and that's fine. And then biological waste, you can just call in a pickup. That's again on our website. So some of the issues we see around, open containers is one of the big ones. The EPA, they're really laser focused on open chemical containers, and we're doing pretty good, and we've had a number of violations for that. So just try as much as you can to put a proper cap on them. You can see that, well, we got a cap on this one, not so proper. And then a lot of times the things that you probably don't use a whole lot are HPLC, and there are ways to get that HPLC waste to go into a container through some small holes. And then, we have a lot of lab cleanouts, people leaving. We would like to do that in a little bit more organized process, but you can see this is not so organized. Again, those are pictures of things that we run into. But I would have plenty of other pictures, but contact us early if you know you're going to have a clean out with a faculty member leaving or a big one, and we can help make that an easy process for you. One of the things that we're trying to do is develop some checkout procedures for all of the departments. Chemistry has a pretty good one, and we may share that on our website, is that when a graduate student leaves, here's the checklist. And they clean their area and either transfer chemicals that are useful, and then a lot of times, well, we need to save these samples, but it's important to get those labeled properly, that we have them for a certain period of time. Let's say the research project is over, and then somebody can say, now it's time, we can get rid of these samples. So I am open for questions, complaints, suggestions. But again, Yeah, all those things at any time. Send me an email and we'll respond back. I'll get the right person in contact with you.
While they're still thinking about some questions, there's one that's come up for us, especially in the safety committee, because there are some labs in this building that are shared by several researchers. And the work that they do need not necessarily be the same or similar. And so the concern we would have is, let's say that one corner of that space is being used for manipulating chemicals, and another corner there's a machine there, and so they need eye protection and so on. Each of the researchers will fill out their own forms, but it's possible that some of that chemical spills over, or there may be fumes from that chemical while they're manipulating it that could affect other parts of that lab. And so we were struggling with the right way to figure out, primarily not so much to meet OSHA requirements, but figure out what does it take to keep everybody in that lab safe. And so we wondered if you had any advice or suggestions on how we ought to manage those multi-researcher labs.
Well, I think if there's a process going on in that large lab that could expose everybody in that lab would need the appropriate personal protective equipment. Let's say there's a large mill, or I don't know what I could figure out that might shoot off pieces, then everybody in there should have eye protection. That's the difficult process, is that when you have a laboratory, a lot of times you think, oh, there's something going on in that hood across the room. Well, there are plenty of examples where, for example, a pressurized flask, or a flask that wasn't meant to be pressurized, has exploded and sent shards of glass across the room. And so if an individual wasn't appropriately protected, they could be injured. So I think it's an evaluation of the potential for exposure of those individuals.
One of the things, just to follow up, one of the things we're trying to institute to the extent that we can is get more conversations going amongst the members of that lab space, so that they can communicate potential hazards, and then thereby decide, oh, we better all get trained on this particular thing or get the right PPE. So, but the first step is to recognize what each other is doing. Right? So.
I think, and it's about the communication, and we can certainly help in putting that in perspective, that, yeah, it might be advisable to do that, or communicate when certain operations are taking place. Yes, sir.
The other groups in these multi-research labs need to get their separate ISPs, or does the whole lab present one?
Well, it would depend. And so the question was, is there multiple? If there's multiple researchers, do you need multiple ISPs?
And the way we've done it anyway is that each researcher fills out their own form. And I'm not saying that's the right or the wrong way, but that's how we've been doing it. And so there is sort of a separation then, and not necessarily a combination of all the information at once.
And that's also another factor is the person filling out the form familiar with everything that's going on. And so that's probably why it makes sense to have multiple ISPs even in the same room.
Jim's going to be here till at least 1, so there's still
That's right.
for questions.
And then I'll give you your homework.
We have it.
Yeah, you do have your homework.
Is there 2 different forms then for the right to know, or for hazardous communication? One for the refresher and one for the initial?
You mean the training?
Yeah.
No, there's, okay, now there's
There are 2, right?
There's 2. One is an awareness form. So the awareness one are typically for people who use chemicals seldomly. So, for example, let's talk about a clerical staff who might use Windex to clean the office.
Okay.
And they do that once a week. That's consistent with household use of that. So they would take the awareness training, the 15-minute awareness training online. Now, an individual that uses adhesive, paints, things, cleaners on a regular basis, not like you would use at home, then they would need to take the 45-minute training. And so there is a big difference, but we want everyone to take the 15-minute awareness, so then they know, okay, when do I need to take the more in-depth portion of that hazard awareness training. Yes, sir.
What are the PPE requirements for soldering?
The PPE requirements for soldering. I would say that my hazard assessment, and this is my personal opinion, would be probably safety glasses, or or perhaps goggles. I don't know. Typically, somebody may say, well, I want to wear some heat-resistant gloves, but then you have a dexterity thing, or perhaps you wear something on one hand that you have to hold with to prevent a burn. But I would say typically just safety glasses.
In training to teach the subject what end of the soldering iron to pick up. Well, you make up of them.
Yeah.
You're thinking
yeah.
safety glasses for electronic soldering?
Yes.
Okay.
Yes. Yeah. Safety glasses for electronic soldering. And that's why it's always good to have an SOP, which end of the soldering iron to pick up. Yes.
We only make the mistake once.
Yes, you do. You do.
They make it more than once, we're changing professions.
Yes, sir.
Is the refresher training that has been mentioned in the form, is that the awareness training, like that everybody should take annually, or like what exactly is this?
What is the refresher training? Well, let's say, are you talking about laboratory safety?
Hazard communication.
Yeah, well, it's just the original training. We don't have a refresher training, so just go to our website and just retake that training. That's the best advice. Yes, sir. That's the best advice we have right now. We would find it, I think, difficult to develop a refresher training for that, but I'll ask my staff if perhaps that might be something that might make sense for the future. But 45 minutes really isn't too bad, at least in my opinion. Some people might say, well, that's onerous, but we could discuss that for a while, I'm sure.